Welcome. We're going to be doing Physics 220 E&M Waves, where we're going to be looking at microwaves in particular and some of the properties that they exhibit. What we have here is a microwave source, which is currently flipped on. They're 3 centimeter wavelength microwaves, and they're just coming out of here. The cone, plastic cone thing is to help focus them down so that they're coming just straight out. These waves are going to come out and they're going to reflect off this metal surface and then kind of come back, and so we actually see a phenomenon called which is known as standing waves, where we have the waves bouncing back and forth. In order to detect these waves, we have just a simple antenna. The antenna is these 2 leads here. It's just a strip of metal in this thing, and each lead is connected to a voltmeter, 2 leads of a voltmeter. And so what we do is, when we place it in the air, we're detecting any voltage difference from here to here. And so what we can do is, by different orientations, determine how the electric field is oscillating from the microwaves. We also have another antenna set up here. This one is on this voltmeter, but there's a nice little knob here that allows us to move it back and forth. One thing that you'll notice is that the voltage changes to 0 and then maybe up to like 3-ish as we move, or actually went up to like 15 there. But basically, we've got this kind of phenomenon where there are certain amplitudes and certain nodes where it's 0, and by just moving back and forth, we're detecting, basically mapping out this kind of sine standing wave. And so that's the equipment for this lab. So for the first part, part A, we're going to try to find the polarization direction of the light, and we're going to be using this antenna here to do that. And so I'm going to hold it at these 3 different orientations as shown on your student sheet, holding it in the path of the microwaves. So I'll go ahead and just start by holding it flat like this, and you can see the voltage there. Now it is picking up a little bit. This is in millivolts, and so I get 0.26 millivolts is kind of background. There's nothing really there. It's pretty close to 0. But if I change it to like this, excuse me, change it to here, we're seeing much higher voltages. And it's oscillating because the microwaves are oscillating, right? But we're definitely seeing something that is non-zero in the voltages. And then the final orientation to check is holding it like this. And again, we're at pretty low voltages compared to what we had before. So I'll run them through them one last time. So those are the 3 orientations, possible orientations. Should be all the information that you need to find the polarization. And that's it for part A. For part B, we're going to look at the standing waves and try to characterize the wavelength, which should be around 3 centimeters because that's what it's labeled on our source. So we're starting pretty close to the wall here, and I'm just going to slowly move it out, and we can see the voltage change. So it's going up, 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 up to about 12, and now it's going back down. And where it's 0 is where we have a node, and that's the distance that we're going to want to record. So it's pretty close. So here on there's a little centimeter ruler here, and we're maybe at 2.05 or 2.1. If we work from above, it might be easier. Okay, so that's the first X value, I guess you could call it, that we're going to record where there's a node. Now I'm going to go ahead and move it out further until we get to another node. Trying to find exactly where it is. Went too far. Okay, that's pretty close. Okay, let's go ahead and look here. Alright, so there's the next X value for the next node, and we can go ahead and move it out again. Go to the antinode, and here we are. I went a little bit faster this time. I'm just trying to move it back and forth until we get to the lowest voltage that we can, which might be around it's really hard to move it really slow. Okay, this might be as close as we're going to get on this one. So, around here. Okay, and we need to do 5 of these, so we have 3. So moving it out, back to the next node. Okay, about there. All right. And if any of these measurements are too fast, you can always go back and pause it and to make your own measurement there. But this should be the last one that we need. Okay, looks pretty good there. All right, so that's the final node where it is at 0 voltage and 0 electric field, I guess you could say. And so from there you can find the wavelength, and then from that the frequency, and that's going to be it for the lab. And this is actually the last lab of the semester, so appreciate you being patient and trying to learn as much as you can from these remote labs. Hope that you're staying safe and healthy, and have a good rest of your semester.